When I look at number 1, it says, first off, we're going to round all answers to the nearest tenth, and we're going to show all of our work. So when I look at this, I see my right angle. I look directly across, and that would be my C value. So I'm going to go ahead and label that, and then I'm going to say this is A and this is B. And I want to find the missing side, so as always, I'm going to write my formula, A squared plus B squared equals C squared. And then now that you've already labeled your triangle, you're literally just going to plug in each of those values. So just as we labeled it on the picture, we're just going to substitute those values into your formula. So 2 squared, 2 to the second power is 4. 5 to the second power is 25, is equal to C squared, which is our unknown. These two terms are on the same side of our equation, so we're just going to combine our like terms, which is 29 is equal to C squared. And so then in order to isolate C by itself and get that distance, we're going to take the square root of both sides. So C is equal to the square root of 29. And when I type that in my calculator to the nearest tenth, I do get 5.4 inches. Now, one thing that I would like to remind you of, if there are units in your problem, like here, then I would expect to see units in your answer, okay? Therefore, problems in context should have units. If you are given a triangle without units, then I would not expect to see units in your answer since you don't know the context, okay? Number 2, again, we're going to look for the right angle. We're going straight across, and that would be our C value. And again, A and B can be either of the legs. It doesn't matter because addition, A squared plus B squared, is commutative. So it does not matter which one is A or B. So A squared would be 14 to the power of 2 plus B squared is 3 to the power of 2, which is equal to that C squared. So 14 to the second power is 196. That is one of our known values that we memorized at the beginning of the year. However, you can always use your calculator. And 3 squared is 9. When I add those two, and I am adding them because they're on the same side of my equation, so I'm just going to combine, I get 205 is equal to C squared. Again, the undo of the second power would be to take the square root of both sides. And so you get C is equal to the square root of 205 because that's not a perfect square. And when I type that in my calculator, I get 14.3 to the nearest tenth. And then my unit is indeed inches, okay? All right. Number 3. Looking at my right angle, as always, go straight across. That would be my C. I got A and B. So A squared plus B squared equals C squared. And so A in this case is 12 to the power of 2 plus B to the power of 2 is equal to C to the power of 2. 12 times 12 is 144 plus B squared is equal to 225. Now, notice in this case, here's my equal sign. My like terms are on opposite sides. Therefore, I can't just combine my like terms. I do have to move those like terms on opposite sides of my equal sign to get them together. So when I subtract 144 from both sides, bring down that B squared, I get 225 minus 144 is 81. And just like all the other times we've done this, take the square root. Now, 81 is a perfect square, and so I get 9, with my units being yards. Okay? Number 4. Again, like always, right angle, straight across, that's your C. It is worth taking a moment and just labeling all your parts on your triangle so that you don't make a silly mistake. Okay? Take that 30 seconds to do that and write your formula. Do both of those things. Okay? Okay, a squared plus b squared is equal to c squared. So I get a squared plus 6 to the power of 2 is 36. Is equal to 9 times 9 is 81. Again, I have terms on opposite sides of that equal sign. So I do have to do opposite operations or inverse operations in order to get those like terms together. And so when I do that, I get a squared is equal to 81 minus 36 is 45. And again, we take the square root of both sides. 45 is not a perfect square, so I have to type that in my calculator. And when I do, I get 6.7 feet. Okay, oops, I probably should have abbreviated just like the rest. Okay, 6.7 feet. So there's our answer, okay? At any point here, you can pause to try these on your own, check your work. Right angle, straight across. So that's my C, A, and B, okay? So again, do you have to write the formula every time? Necessarily? No. However, is it my absolute recommendation in my professional opinion? Yes, it is, because it will help you to avoid silly mistakes. Okay, a squared plus 1 to the power of 2 is 1. We're not saying 1 times 2, we're saying 1 times 1, which is 1. And 4 to the power of 2 is 16. Again, we have like terms on opposite sides of our equal sign. So we're going to do inverse operations and subtract that 1 and get 15. Take the square root of both sides and you get a. That's not a perfect square. So I'm going to type root 15 in my calculator and I do get to the nearest tenth, 3.9 yards. Okay. Last one on this type of problem. The number one mistake I saw when we were doing our initial practice problems is that we would look for that biggest value and see, oh, hey, 11 is our largest value. That's our C. But remember, when you're given your triangle, you identify your right angle, go straight across, because you don't know that your hypotenuse, your largest value, can be your unknown, and so you're not going to necessarily see it visually as your largest value until you have solved for it. So it's always a good habit just to verify with your right angle. Again, that keeps you from making a setup error, and therefore you have everything in its place. So 7 times 7 is 49. 11 times 11 is 121, is equal to C squared. Again, these are on the same side, so we don't have to do inverse operations. We're just going to add. 49 plus 121 is 170. Taking the square root of both sides to get rid of the squared. That's not a perfect square, so I get C is root 170, which when you round to the nearest tenth, I get 13.0 inches, okay? And it's not 13 exactly, which is why we have to include that 0.0, okay? If you have any questions about these first ones, let me know. Otherwise, these should be pretty straightforward. If you recall, the purpose of using the converse is you're given the side lengths and you're trying to prove if you have a right triangle, and the answer, so when it says state the answer, well, part of it should be yes or no, and not only what is it, but we're giving a reason why. And so when we have the converse, you can do this one of two ways. I know some people liked to draw like a triangle figure, and have like your 6, 8, and your 9. Remember that your 9 would have to be on that across from the right angle if it is a right triangle. You also don't have to do that. You can just, your biggest side is going to be C, and then your other two are going to be A and B. So I have A squared plus B squared is equal to C squared. And so I'm trying to figure out, like, is this going to be true? So 6 squared plus 8 squared. I'm saying, is that equal to 9 squared? Well, 6 times 6 is 36. Plus 8 times 8 is 64. And I'm saying, is that equal to 9 times 9, which is 81? And so 36 plus 64 make 100. And I have this 81, and those are not equal. Therefore, so I showed my work, stating my answer. Side lengths six, 9, and 8 are not a right triangle because, or since, and then I'm just going to state my Pythagorean theorem statement. So 6 squared plus 8 squared is not equal to 9 squared. So essentially we're just saying our Pythagorean theorem doesn't work. And in case you're confused, let me change colors there. I got this right here from this initial Pythagorean theorem statement, except instead of saying they're equal, I'm saying they're not because this did not work, okay? Let's look at number 8. So again, my C is my biggest side, and then I just have A and B. So A squared plus B squared equals C squared. So 5 squared plus 12 squared, is that equal to 13 squared? Well, 5 times 5 is 25, plus 12 times 12 is 144, is equal to 169. So I'm trying to see, does that work? And when I use my calculator, 25 plus 144 is 169. Okay, so that does work, okay? So when I give a reason for my answer, very similarly to what I did over here, I'm going to say side lengths of 13, 5, and 12. 13, 5, and 12 are, so instead of saying are not, we're saying they are a right triangle. And again, I'm going to use that initial statement. Since 5 squared plus 12 squared is equal to 13 squared. Okay, and again, that's that initial Pythagorean theorem statement that I made, trying to show if this works or not, okay? So, when I have that, I'm just writing my reason, okay? Now, let's look at number 9. Again, at any point, you could pause this to try these on your own. Hopefully, you've already done that by the point you're watching this video, and this is just for clarity's purpose. So, A is 40 squared plus 8 squared. I'm saying, is that equal to 41 squared? Well, thank goodness this is calculator active. 40 times 40 is 1600 plus 8 times 8 is 64 is equal to 41 times 41 is 1,681. And so when I add up 1600 plus 64, I get 1664, and that is not equal to 1681. So, again, stating my reason, side lengths (48) and 41 are not a right triangle. And again, I'm going to use my statement, since, or you could even say because 40 squared plus 8 squared is not equal, this did not work, to 41 squared. Okay. Last one on the converse. So again, my biggest side is C, and then the other two are A and B. And again, just like always, I'm writing my formula. That keeps me from making a dumb mistake when it's completely avoidable. So I've just plugged in just like I've labeled it. 9 times 9 is 81, plus 13 times 13 is 169. We're saying, is that equal to 225? And when I add those up, I get 250, and that is not equal to 225. Therefore, side lengths uh, 9, 13, 15 are not a right triangle since 9 squared plus 13 squared is not equal to 15 squared. Okay? And again, if you're wondering where these statements are coming from, it is that initial plugging in of the Pythagorean Theorem is where I'm getting those, okay? So, again, if you have questions about the converse, please make. Okay, now let's talk about word problems. So if you recall in class, we talked about how the key to being successful with word problems is really being successful in drawing the picture, okay? So I'm going to spend most of my time talking about the picture, and then I'm going to quickly talk about the Pythagorean Theorem part, okay? So looking at this first one, remember we go one statement at a time. So you have two joggers run 8 miles north and then 5 miles west, okay? So I'm going to start with, so let's just say we start here. And you're going to go 8 miles north, okay? And they turn and they go 5 miles to the west. Now, if I go from north to west, I'm definitely creating a right angle. What is the shortest distance to the nearest tenth of a mile, okay, that they must travel to return to their starting point? So when we're looking at this now, we're talking about from where I ended, going right back here to our start point. And that is what you're looking for, okay? Now, again, right angle, straight across. So my D, my distance that we're looking for is actually like the C value in this case, okay? And so that's A and there's B. So A squared plus B squared is equal to C squared. And I'm not going to spend as much time on this because we really have talked about this a lot. I'm just going to go through this part quickly. And so 5 squared is 25, and 8 times 8 is 64, is equal to the distance squared, and so that is 89. And when you take the square root of both sides, you get the distance being 89 is not a perfect square, so it's the square root of 89, which when I type in my calculator, I get 9.4 miles. Okay? Now, number 2. The foot of a ladder is placed 6 feet from a wall. So there's your first statement. The foot of a ladder is placed 6 feet from the wall. Okay, so let me go ahead and draw a triangle here. So here, this side here is going to be my ladder leaning up against my wall. So then this side here is going to be your wall. And then down here, of course, would mean we have the ground, okay? So the foot of a ladder is placed 6 feet from the wall. So that means there's the 6 feet. If the top of the ladder rests 8 feet from the 8 feet up on the wall. So that means I know the top of the ladder reaches up to a height of 8 feet. And they are asking, how long is the ladder? That's your question here. Okay, so again, hypotenuse, so that means my x is my hypotenuse in this case, so it's my c. So a squared plus b squared is equal to c squared. And I forgot to label this, a, b, and c. So 6 squared plus 8 squared is equal to x squared. So that's 36, and 64 is equal to x squared. So we get 100. And when I take the square root of both sides, I get x is equal to 10 feet. And so I had a 10-foot ladder. Okay? Let's look at these last 3 here. It says, what is the length of a diagonal of a 10 centimeter by 15 centimeter rectangle? Okay, this is probably the easiest one. Okay, so you're literally just drawing a rectangle. We're trying to find the distance or the length of the diagonal. All rectangles have a right angle. And so I get my right angle there, and then I'm just filling in with my dimensions that they gave me here. 10 by 15, okay? So A, B, and C. A squared plus B squared equals C squared. So that's 10 squared plus 15 squared is equal to the unknown distance. And so again, we're typing these in our calculators. At this point, that should be absolutely old hat and a non-issue, okay? So when I do all that, I get 325 is equal to the distance squared. And so when I take the square root of both sides, I get 18.0 centimeters. And that's my answer. Okay. We have another rectangle problem here. It says a soccer field is a rectangle. Okay. Let me go ahead and draw my right angle here. We know it's 90 meters wide and 120 meters long. The coach tells them to run from corner to corner, and we want to find the distance of the diagonal, okay? So, right angle, straight across, that is my C. And the other two don't matter. So I get A squared plus B squared is equal to C squared. So again, I'm just plugging in 120 squared is 14,400. 90 squared is 8,100. And when I add those together, I get 22,500 is my unknown. And so to take the square root of both sides, again, thank goodness for calculators, you do get 150 meters exactly. Okay. And last word problem, we have Donna's TV screen, which is 20 inches long. Okay, so I'm going to go ahead and label that length. Then it says if the diagonal is 25 inches, so we know this, and we know it's a TV screen, so there's my right angle, and it wants to know what is the width. What is the width of her TV? We have no idea. Now, again, right angle, straight across, your 25 is your C this time. So C, A, and B. So if I go ahead and A squared plus B squared is equal to C squared. And so I get 20 squared plus my unknown W is equal to 25 squared. So I get 400 or 20 squared, and 25 squared is 625. These are on opposite sides, so I'm going to subtract 400 from both sides of my equation. So W squared is 225. And when I take the square root of both sides, I get W is equal to 15 inches. Okay? If you have questions about word problems, okay, the last topic that we're working on is distance between points on a coordinate plane, and again, we're going to round to the nearest tenth. So on the first two, notice that I have given you the line. I've already got these 2 points graphed for you, and so the easiest way to find that diagonal distance between 2 points is we're actually just going to create a triangle. And I'm going to do that by creating a flat base, okay? And I'm going to count my spaces. So I went 1, 2, 3, 4, 5, 6, 7 spaces. So that's a distance of 7. And going up, that is a distance of 1, 2, 3, 4, 5. And again, when I make that immediate turn, I'm creating my own 90-degree angle. So 90-degree angle, my distance is the hypotenuse. And when you are finding distance on a coordinate plane, D is pretty much is always going to be your hypotenuse, unless you're trying to find one of the dimensions of how far you went. But if you're just trying to find the distance between 2 points, then the distance is going to be that hypotenuse, pretty much every time. So I've got A, B, and C, aka D in this case. So A squared plus B squared is equal to C squared. And so my A, in this case, is 7 squared plus 5 squared is equal to my unknown distance squared. 49 and 25. Again, we've done this so many times. So at this point, I am really not going to spend a ton of time on just plugging it in, because that is the very first thing that we did. So I'm taking the square root of both sides. The distance 74 is not a perfect square. So when I take the square root, it doesn't come out perfectly, but to the nearest tenth, it is 8.6. Now, notice I don't have a unit, so my answer is just 8.6. Like I can't do anything more with that because I don't have any units in this particular problem. Okay? All right, let's look at another one. So again, I am just going to draw my right triangle in order to make this where I can find the distance. Okay? So I am just going straight across or straight up and down. Like those are the only two options. So I went down one space here, and then 1, 2, 3 across. And again, this is the distance that I'm finding. In this case, it's relatively short. So A squared plus B squared is equal to C squared. My A in this case being 1, my B being 3, and my C is that unknown distance squared. So when I work that out, I get 1 plus 9. And so that tells me the distance squared is 10, which is not a perfect square. And so when I take the square root of 10, type it in my calculator, I get 3.2. And again, in this particular example, I am not given any units, so I have no units to even put on this, okay? Let's look at number 18. It says a coordinate plane is placed over the map of a town. A library is located at -5, 1. So I'm just going to count 1, 2, 3, 4, 5, and then -1. So right here, and I'm going to put an L for a library so I can come back to that later. And then says a museum is located at 3, 5. 1, 2, 3, and then 1, 2, 3, 4, 5 right here at the top. Okay, so there's my museum. It says what is the distance to the nearest tenth from the library to the museum? So I'm looking for that diagonal distance, just like before, going straight across. And I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go straight up and down. Put my right angle. 1, 2, 3, 4, 5, 6. And so now when I do the Pythagorean theorem, a squared plus b squared equals c squared, I get 8 squared plus 6 squared is equal to the unknown distance squared. So 64 and 36. D squared is equal to 100. And the only way to get rid of that squared is to do the square root. So D is equal to 10. And again, I was not told any units on this one because I just have it's located at these places, but we're not told anything about distance. Okay, number 19, Coach Adams drew his football team's play on a coordinate grid. He placed J at positive 2, 1, okay, 2 over and 1 up. So there's J, and he placed, he was passing the ball to Sam at negative 4, negative 3. So there is negative 4, negative 3. Again, be sure, 1, 2, 3, 4, 1, 2, 3, yep, and 2, 1, 1, 2, 1. So, again, this is the distance we're finding. So you're just going to go straight down till you get to the right grid line. 1, 2, 3, 4. And then across where they meet at a right angle. 1, 2, 3, 4, 5, 6. Okay. So here's my Pythagorean theorem. So I get 4 squared plus 6 squared is equal to my unknown distance squared. So when I work that out, I get 16 plus 36, which last time I checked is 52. And so when I take the square root of both sides, I get, the square root of 52, I have to type in my calculator, and I get 7.2, and I know it's yards in this case because it says, what is the distance in yards from J to Sam? So, like, they tell me right there, I'm looking about yards. And last one, we have a map, we have Maya, and we have Jasmine. So, positive 4, negative 1 is Maya's house. Negative 5, positive 4 is Jasmine's house. So there we are. Positive 4, negative 1, negative 5, positive 4. Yep. So now I just go straight down and count. So 1, 2, 3, 4, and then one more. And then straight across. 1, 2, 3, 4, 5, 6, 7, 8, 9. So a squared plus b squared equals c squared. So again, my a and b do not matter as long as you get them both. So 1 and 81. So that would be 82 is d squared. Take the square root of both sides. So d is equal to the square root of 82, which is, wait a minute, did I make a mistake? Oh, I put a 1 here. Why did I put a 1 there? I don't know why I just caught that. 1, 2, 3, 4. That should be a 5. Well, good thing that everybody makes mistakes. And I caught it before I had finished my problem, which makes me happy. So 25 and 81 make 106. And so when I take the square root of 106, I get 10.3, and we know it says to the nearest tenth of a mile, so my answer is in miles. Okay? If you have any questions, again, with these, you're just plotting points, connecting them, and drawing your triangle.